Hello guys, this is CodeNCode and this is video editorial for the problem counting rooms taken from CSES. So the problem is we are given a grid of size n cross m. Each cell represents either a floor or a wall, and from a cell we can move either left, right, up or down in 4 directions basically. Each from a cell you can move to any other cell which is having a common side with the current cell. So we have to count the total number of rooms in the given given grid. Problem may be difficult to understand. Let's understand it with an example. So this is an example. First of all, let's see the constraint. These are n and m can be as large as 10 power 3. Now this represents one configuration and we see the number of rooms are 3. We see these hash represents wall. Okay, in the problem it is explain that the hash represents wall and these dots represents floors. So you see, of course 2 rooms will be separated by wall. So you see these 2 form a single room, these 2 form a single room, and these form a single room. So in total there are 3 rooms. So that is why we are printing 3. First of all, this is a practice problem for DFS on grid that I have been teaching from last 3 or 4 lectures I guess. So if you haven't seen that and you do not know how to count the connected component on a given grid, because the problem is nothing but count total number of connected component even in a given grid using DFS or BFS, whatever you like to apply. Now if you have not watched those lectures, if you do not know how to count connected components on a given 2D grid, then please go and watch those lectures first. So what you have to do is nothing, just count the total number of connected components. I have already explained how to do that. Let me show you the code. So this, as you can see, I have solved this problem and this is how we solved this problem. I've taken an array for input of size 1000 cross 1000, and then this is to keep track of visited cells. Of course n and m, the n and m in the input. So this is valid function. As again I have already explained all of these in the previous 3 or 4 lectures in graph theory playlist part 1. So if you haven't seen these lectures, just go and watch those lectures first in the playlist graph theory part 1. Now is valid function, as you can see, this is the normal thing. The only thing you need to take care of this, the rest code always remains same. This is what we have added extra. We cannot jump to any cell which is having hash stored in it. So we will move from dots to dots only, from dots to dots, but not to hashes. And now since we can only go up, right, down and left, there are only 4 possibilities. So this is for up, right, down and left. So we'll make these recursive calls, and of course here I'm reading the input, and then as explained in the previous lecture, in lecture 19 in graph theory playlist part 1, how to count connected components. So we run a loop from of course we run a loop for each, we check for each given cell whether the cell is visited or not, and of course this should be a floor. If this is a floor and this cell is not visited, we will make a DFS call to that cell and of course increment the connected component count and finally print it. As you can see, this was really easy to implement. So if you have any doubts or query, of course you can ask on the article that I have created for this course. The link of the article I'll be putting in the description of this video. So this was all for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.